Okay, so I am recording now. I'm going to go to share my note screen with you so we can talk about this stuff. Okay. So you should see my note screen. Oh, somebody's been playing with my notes. I'm writing really fat, huh? Okay, so let me fix that. Okay, the blue one seems to be right. All right, so this is 12.5. And like I said, it's called related rates. So I'm going to put an example problem up with just letters and numbers, no application yet. But once we get the hang of it, we are going to be looking at applications because most related rates problems have to do with applications. So, but we'll just look at a regular numbered example first so we can understand what's going on. So we are going to be looking for derivatives. So remember with implicit, we did a lot of finding dy dx. Well, we're going to add a new variable in there when we're talking about rates. So this problem starts by saying it wants us to find dy dt. So we're used to the derivative of y, but you guys notice we're with respect to t, and you might think, oh, well, maybe t is just the input variable instead of x in this problem. But you're going to see that that's not the case, you guys, because I want to find dy dt when x equals 1, y equals 2, and dx dt equals 3. So I have a lot of information to unpack here. And then it's not even done. It says, I want you to find all this given that y cubed equals 2x to the 4th plus 6. Okay, so this is a lot. The first thing I want to say is that when we see the word rate, you guys, anytime you think about the word rate, it implies a change over time. And your time variable is t. That's why we see those dt's in there. I want to know how, what does this say, dy dt? I want to know how y is changing over time. When I have a fixed value of x equals 1 and y equals 2, notice I'm given dx dt, which means I know how x is changing over time. And that value is 3. Sorry. And then I have this equation that relates x and y. So notice x and y are related, and I'm trying to find the rates of x and y. So you guys, what you're always going to have, you're always going to have an equation that relates two variables. Notice there's no t in this equation. It's just a normal x and y equation like we've been dealing with. But it keeps saying I want to find dy dt and dx dt, but I don't see any t's in the problem. So you guys, I want to write out some steps as we're working these. Now this x equals 1, y equals 2, you might wonder, you know, where that applies. Do I put those values in for x and y now? Do I even use them at all? Remember in implicit, what we just did when we found dy dx at a point, we took the derivative first and then we put those values in for x and y. That's what's happening again here. So step 1 is to take the derivative of the equation. So it is going to be implicit differentiation, but here's the kicker, guys. I want to take the derivative of this equation with respect to time. And we'll talk about how to do that next. But after I take that derivative with respect to time, that's when I'm going to plug in the given values, like the x equals 1 and the y equals 2. And you guys, there's actually going to be a place to plug in this dx dt equals 3. And really, that's all there is to it. It's kind of a two-step thing, just like finding the dy dx at a point. You take the derivative, and then you put the point in and solve for dy dx. It's the same thing we're doing here, except for this time, we are going to take the derivative of every term, not with respect to x. We're going to do it with respect to t. So, you guys, when we have y in an equation, just like a normal, like from the last section, from any other section, we've always taken the derivative of y with respect to x. That's why we have that dy dx that shows up in those equations when I take the derivative. When I have just an x and I'm taking it with respect to x, we don't usually write it this way, but I know that the derivative equals 1. You guys, another way to see that, what I'm doing there is I'm taking the derivative of x with respect to x. So you guys, you can see how this fraction just turns into a 1, and it never shows up in my equation because I'm taking the derivative of x with respect to itself. So you guys, this is what we're used to. We're used to having to do this, but I want to take the derivative of everything with respect to t this time. So this is the old stuff. This is the 12.5 stuff. When I take the derivative of y, sorry, I'm going to take the derivative of y with respect to time. So every time I have a y term in my equation and I take the derivative, that dy term that I tack on is not going to be dy dx, it's going to be dy dt. And when I take derivative of an x term, you guys, it's not going to be dx dx and it just goes away like it always has, because I'm not taking with respect to x this time. You guys, I'm going to take the derivative of x with respect to time. So it's going to get its own add-on term. You guys, so I like to say when you're doing related rates, everything gets a dt. We're not used to having to add something on like this with an x term, but now we are. We're treating x and y both as functions of time. And no, you're not going to see a t in these equations. And that's okay. You guys, when you take the derivative, you will just add in that dt. It says we're taking both derivatives with respect to time. That's how you get a rate. Okay, so let's get started with this example. So in step 1, remember it just says take the derivative of the equation with respect to time. So let's do that. Let's rewrite our equation. I have y cubed equals 2x to the 4th plus 6. And just like the implicit last time, you just go term by term and you take derivatives. So it works just like any other implicit. Y cubed becomes 3y squared. But instead of adding on a dy dx, we add on a dy dt because we're going with respect to time. Now let's think about the 2x to the 4th. So 4 times 2 is 8. We get 8x cubed. So normal power rule happening. But because we're going with respect to time, sorry, we get a dx dt. Everything gets a dt. Now the plus 6 just goes away because it's a constant. But now we're here. So once we've taken the derivative of everything, now we plug in the given values. So our given values were x is 1, y is 2, and dx dt is 3. Let's get that written down. So you guys notice in this equation, there is a place to put all 3 of those values. So if y is 2, this 3y squared becomes 3 times 2 squared, dy dt. X is 1, so we get 8 times 1 cubed. And then dx dt, I have a value for that too. So put in that as a 3. You guys, what you're going to find on these problems, they always give you a value, an XY point, and one of the rates. They gave me the rate for X. What I'm looking for is the rate for Y. So let's finish this off. Be careful with order of operations here. This is 3 times 4, so we get 12 dy dt equals 8 times 1 times 3, so equals 24. And then divide both sides by 12. And we just get dy dt equals 2. So very much like the implicit that we've been doing, but we are taking all derivatives with respect to time. So every derivative gets that extra piece. Okay, so let's do another one. We're just going to do a bunch of examples, probably 2 more numbered examples, and then we'll look at some applications.
Can you scroll up for just 1 minute?
Oh, yes, I sure
can.
1
second, I apologize.
Definitely. Here you go. Let me see. Which one do I want to do next? Oh, this one looks good. All right,
okay,
guys.
You're good. Thank you.
Okay, thanks. So let's find on this example, this time I want to find dx dt when, let's see, find dx dt when x equals, sorry, x equals 0, y equals 1, and if I'm looking for dx dt, it has to give me dy dt, and it does. It says dy dt equals 5. And this is given that x and y are related with the following equation. 2x to the, 2x to the 5th plus x. So 2x to the 5th plus x equals y squared minus 1. So we recognize that we have an equation relating x and y. I'm going to take that equation, take the derivative of every single term with respect to time. Okay, so let's start with this first term. You guys, that's going to be 10x to the 4th. Don't forget, everything gets a dt, so dx dt. Plus, well, the derivative of just x is just 1 dx dt. Over here, we have a y squared, so that's going to be 2y dy dt. And then the minus 1's going to go away. So now is the time to plug in values that you know. So it says x is 0. So you guys, what happens to this entire term? It's just going to go away because you're going to put a 0 in for that x. So that whole term's gone. This term is still going to be 1 dx dt because I don't know any values to plug in there. But over here, y is 1, so I'm going to have 2 times 1 times dy dt, which is 5. So you guys, 1 dx dt, well, that's just dx dt. That's what you're looking for. And it just equals 10. So just like implicit was, you guys, you'll notice that even if, you know, you get to a point that looks a little more complicated and you're like, oh, I'm going to have to combine these terms. And, you know, sometimes you will, but sometimes when you put in your point, it gets a lot simpler. Like this one got extremely easier. Let me pick another one. Sorry. Let me see here. Let's do one that has the product rule in it. Let's look at how product rule works when we're doing related rates and everything gets a dt. So I want to find dy dt when, let's see, Find dy dt when x equals 2 and y also equals 2. I know dx dt this time, and it equals 1. And my equation that relates x and y to each other is xy equals x plus y. All right, so you can see where we're going to have to use the product rule here because I have x times y. So let's go over to this side and get some u and v. So u equals x, v equals y. So you guys, the derivative of u, be careful because it used to just be 1 when we were doing implicit, but it's 1 dx dt because everything gets a dt. The derivative of v is going to be 1 dy dt. So when we put these together, let's see what happens. We get u times derivative of v, so we get x times dy dt plus v times the derivative of u, and then so we'll have y times dx dt. So we did the product rule. Over here, the x plus y, well, take the derivative of x and you're just going to get dx dt. Derivative of y is just dy dt. So from here, put in the values that they gave you. So x is 2. We don't know dy dt, so just 2 dy dt plus y is also 2, but I do know dx dt is 1. Here's dx dt again, so that's just going to be a 1. And then we'll have plus dy dt. So notice the only variable left in the equation is dy dt. I need to get them together on one side and get everything else on the other side. Let's start by subtracting 2 to pull that over. So I'll have 2 dy dt equals, so this is 1 minus 2, so it'll end up being a negative 1 plus dy dt. And then let's get this dy dt over on the other side by subtracting it from both sides. So I have 2 dy dt's minus 1 dy dt, so that leaves me with 1. So it leaves me with dy dt equals negative 1. So you guys, when you have the product rule on these, notice that both u and v get the dt. So, you know, you're going to see those show up in both parts of that product rule. Let's see. I think one thing I want to mention, guys, is being careful. You guys, these dt terms start to all look the same. I mean, once you have so many in your equation, make sure you know which ones are dx and dy, you know, and where to sub in for things and where you can't. I think that make sure that your writing is neat and you can always, you know, really make out which variable is which, because it does get confusing. And I've seen a lot of mistakes happen when you mistake a dy dt for a dx dt or vice versa. So you guys, let's look at this one. This one has a little bit of extra, let's call it fun. Let me write it down and I'll talk about why it's extra fun. So you guys, I want to find dy dt. When x equals 1, I also know that dx dt equals negative 4. And my equation is x cubed plus y cubed equals 9. So you guys, do you notice the missing piece? So on this one, notice that we do have x equals 1. It tells us that, but it doesn't tell us what y equals in this case. Oh, why do I always do that? Hold on. I'm trying to pull up the chat so I can, and then it always tells me to stop recording. Uh-oh. You guys, am I freezing and really laggy? My internet looks okay. I wonder if it's Zoom.
Yes.
Yeah.
Somehow your internet lagging. And now your looks like Minecraft all pixelated.
Oh, awesome. Okay, so guys, I am recording this and I'm hoping that the recording won't be so laggy. Maybe that's, that one can only hope that that's true. So hopefully, if we can't get this understood, in real time, hopefully the video isn't laggy. I don't know that that's going to be true or not, guys. But I also don't know how to fix that. And you're getting a lot of feedback? Okay. Huh. I wonder what's going on. Everything on my end as far as like internet access and looks fine.
I think it's Zoom.
Okay.
Because my other class did it.
Oh no. Awesome. So it'll lag on the videos too. Well, that's great. So that's just really great for our class, isn't it?
Yeah, on mine, I'm just showing like a black box in the middle of the screen.
So the black box I can explain. So when I pull up the chat window, I'm not sharing it, so it looks like you can't see it. So the chat window is the black box. When I close it, it should go away.
Yeah, very good.
Okay. So guys, yeah, I don't know. Zoom, and I figure that Zoom, because it's obviously gained so many users in the last few months. I didn't even know what Zoom was, honestly, before all this started. I have a feeling that at certain times they just really must have a hard time keeping up, with the sheer number of users.
That makes sense.
But not giving you a pass, Zoom. Just I get it. So guys, I'll try to continue. If it gets too much and you can't watch, I wouldn't expect you to sit there and just torture yourself. Honestly, I really don't know. Maybe I'll try to make a video, like just pre-record a video later.
It's a good idea.
And then I'll just put it up and it can be all this stuff. Is there a time when it got laggy, like when it actually started getting laggy, or has it been like that the whole time?
Maybe 10, 15 minutes in.
If you started the video from the beginning, that would be awesome.
Yeah, I'll do that. You guys, actually, so if it's still really bad, why don't we just stop? And what I'll do is I'll just get on, make a video, just pre-record a video, and I'll post that. But it will just be me doing this same thing. You guys, I don't want to torture you with laggy video. Oh, so it's not working. It's not laggy for you at all?
It is for me.
Okay, so I wonder what that's about.
And a lot of half and half maybe.
Okay.
For me, it's not lagging anymore, but it's like super echoey.
Echoey, okay. Which is also super annoying, right? Yeah. So,
but it's only when you talk, so I feel like you talking doesn't really matter.
okay. Hey guys, so if it's laggy, if it's not laggy for some people, I'm wondering if the video will reflect that, because it's not laggy for me either. Like when you guys are talking, and I'm recording from my account or, from my computer. I'll just try, guys. So what I'm going to do, I'm at least going to finish this problem. And once the video processes, I will watch it. And if it's laggy, I will make a new video. And if it's not, then we'll just, it'll be fine and you can watch that one. So let me let me finish this one. So the ones who are good, you guys, you know, definitely stay and follow along. If it is too laggy and it's too much to deal with, like I said, don't torture yourself. You know, I'll make sure you get this somehow. But you guys, on this one, I want to tell you, it's a little bit different because it gave us x equals 1, but it didn't give you a y value at that point. And you know, when you take the derivative of this, you're going to have a y in there that you have to replace with a number. So you guys, on these problems, when it only gives you one, it gives you part of the point. Sometimes it might give you the y, or sometimes it might give you the x. But in this case, because we have the x and not the y, I do need to find that y value. And it's not a hard step, it's just algebra, but it is an extra step. So when I know x equals 1, you're going to put it into the equation to find y. So, I mean, as with any equation, if I say, hey, what's y when x equals 1? Well, you're going to stick x equals 1 into the equation to find y. So you guys, when I only give you one of the x, y coordinates, before you do anything else, before you take any derivatives, we're going to find that other coordinate. So if x equals 1, this is 1 cubed plus y cubed equals 9. So, well, 1 cubed is just 1. So let's subtract 1 from both sides since we're trying to get y cubed by itself, and get y cubed equals 8. And then to get y by itself, take the cubed root of both sides. And you guys, you just get y equals 2. Usually these equations that they make you do this on, they're not going to be super hard. That one was really easy. I found my y equals 2. And now I can start the problem with the related rates. Okay, so after you do that, so that is just an extra step. We haven't done any related rate stuff yet. So now I'm going to take this equation, I'm going to take the derivative of each term with respect to time. So you guys, that's going to be 3x squared dx dt plus 3y squared dy dt. On the other side, we'll just have a 0. And then you can plug in all the stuff you know. So you guys, I know that x is 1, so this is 3 times 1 squared. I also know dx dt is -4 plus 3 times y, which I just found, is 2 squared dy dt equals 0. So let's see, 3 times 1 times -4 is -12. Plus, you guys make sure you do the 2 squared first. So 2 squared is 4 times 3 is 12 dy dt equals 0. Let's add 12 to both sides and get 12 dy dt equals 12. Divide both sides by 12. There's a lot of 12s happening right now, but we get dy dt equals 1. So you guys, from here down, it was the exact same as the other problems. I did have to do that extra step because it only gave me one coordinate, so I had to find the other. And if you forget to do that, to be honest with you guys, you'll get to this line here and not have a value to put in for y, and it'll remind you that you need to do that. So it's, if you forget to do it at the beginning, there's a point where you're going to know you have to do it. But it's just easier to notice and get it over with at the beginning. Find your extra coordinate and then continue the problem. Let's see. Oh, I have a lot of chats. Let me see. You guys you have questions, and I'm trying to see what the original question was. I have a question on the one we just worked. Where did the negative dy dt? So you guys, are you talking about this problem right here? Okay, so notice what happened here. So we subtracted dy dt on both sides. And so I had 2 dy dt minus 1 dy dt, and that left me with 1 dy dt. Is that where your question was? Does that, okay. Oh, yeah, you were trying to divide. Yeah, because they're the same term. Yeah, that was just a subtraction from both sides. Sometimes it's hard to remember that these fraction variables are just regular variables. It's like if I had 2x and I wanted to subtract x from both sides, you know, and I'd be left with 1. It works that same way. They're such bulky variables to have to deal with. Okay, guys. So let's save the applications for next time. I'm worried that the video, I don't think the video will be laggy when it when you guys watch it, but I'm just worried that it might be laggy and I don't want to do too much. So let's save the applications for Wednesday. It'll push back a little bit of things. Like, for example, Wednesday was going to be that review day for us, like I was going to put the practice test up later today in this homework. And then on Wednesday, you could ask me questions about it. And then the test would open probably, honestly, as early as Wednesday afternoon after class. But you guys, let's just push all that back one class period. So on Wednesday, we will just finish this and do applications of related rates because they are really important. I don't want to have time to talk about them. Which means that Friday will be our day for questions and stuff. So like I'll have the practice test up by then. All your homework will be up. Well, I say all your homework. It's just this one section that's left. But it'll all be up and you can look at it and have questions prepared for me for Friday. And so what I'll do is I'll just open the test after class on Friday. And then it'll just be open longer. It's not a big deal. When we take our tests online, it doesn't hurt any class schedules to keep it open longer or open it, whenever. So that won't be a big deal. So let's stop there then. I will put up homework for related rates today. It's just that some of it, the applications, if you could probably figure it out if you really wanted to, but you can wait if you want to for the application problems. And then on Wednesday, we'll finish that up. And I'll let you know, I'll get this video processed. If it's laggy, I'll make a new one. And if it's not laggy, then I'll just have that one posted.
So what day is the test going to be?
So it'll open on Friday now. So we'll have, it won't be open on Friday morning because we'll have class on Friday to, answer questions about the practice test, just like we did last time. But then after our class on Friday, I'll open it up.
Okay.
And I was going to have it due, on Sunday with everything else, but since I'm not opening it till Friday afternoon, I'll probably push it out a couple of days, maybe to Tuesday or something like that. All right, guys. So I will just see you on Wednesday then.